Good morning, students. Welcome back to science class on the chapter sound. In the previous class, we had discussed some characteristics of sounds, and also we had discussed the speeds of sound in a different medium. Okay, already you know the speed of sound is maximum in solids, and the speed of sound is little bit less compared to solid in a liquid, and also in less in air. Okay, so why the speed of sound is maximum in solid? So that is due to the uh, in a solid all the particles or atoms are tightly arranged, so then it is easy to travel quickly on the speed for a sound. Okay, but in liquid the particles are in a liquid the particles are arranged loosely, so that's why the speed of the sound reduces. Okay, then if you take a gas, in a gas also the what particles are freely arranged, so there also the speed of sound reduces. Okay, so already we have seen, right, at 25 degrees Celsius, at 25 degrees Celsius the speed of light in aluminum, that is maximum. Okay, the speed of sound is maximum in aluminum, that is 6420 meter per second, which means 6.420 6.42 kilometer per second. Okay, uh, so next move to reflection of sound. Okay, so before that there is one term called sonic boom. Okay, so next one, sonic boom. Okay, the scientist Chuck Berger. Okay, so Chuck Eager, he traveled, means suppose if you are traveling the speed of sound, that is 346 meter per second. Okay, so if you travel, okay, while traveling, if your speed which greater than this speed, then we call that is sonic boom. Okay, so when you travel means you are traveling, if your speed is greater than this speed of sound, okay, then we call it as a sonic boom. Okay, so when you travel the greater than the speed of sound. Okay, so next move to reflection of sound. Okay, so in the previous year you had studied about the reflection of, in the light chapter, reflection of light. Okay, so just to recall, what is reflection of light? So reflection of light means the bouncing back of light is called reflection of light. Okay, what is that? The bouncing back of light is called reflection of light. For example, if you take, this is a mirror, if you pass rays of light here, what will happen? Okay, so this is incident ray and reflected ray. Okay, so incident ray, reflected ray. Clear? So here in the reflection of sound, first thing is angle of incidence is equal to the angle of reflection. Then incident ray, normal, and reflected ray all lie on the same plane. Okay, so this is in a reflection of light. Here also in the reflection of sound, here also everything is same. Okay, so just like a reflection of light. For example, just imagine this is one board. Okay, so this is a table. Okay, so now you will pass light. You will pass light like this. See here. See, you will pass light. So you will pass sound here. Okay, so then sound it will reflect. It will come back like this. Okay. So here we have to use some pipes. Okay, just to concentrate the sound. Here. Okay, see here, why here we should use pipes? Why? Because see, when you speak, what will happen? Sound will move widely. Okay, so just to concentrate our sound energy, in a straight line. Okay, so that's why if you use this kind of pipe, what will happen? So then the entire sound which passes through this pipe only, which means we can concentrate. Okay, otherwise what will happen? The sound will move in all the directions. Okay, now here, so at the point of incidence, here we will draw one line. That line is called normal. Okay, at the point of incidence. So this is, see, I am passing right. So this I am passing sound, this sound energy which strikes this board here. Okay, at the point of incidence, and this normal, it should be perpendicular to this surface. Okay, it should be perpendicular to the surface. Okay, so here, so we should measure the angle between this incident and this light. We call this it. Okay, clear? And this is, we call this is R. Okay. Okay, so here you are passing sound energy, the angle between this sound energy and this normal. So okay, this angle is equal to this reflecting angle. Okay, so this angle equal to this reflecting angle. Okay, because this is angle of incidence and this is angle of reflection. Okay, angle of reflection. So here, see, you will pass light here, right? So we call this is angle of incidence. Then that sound, sorry, light, not light, it's a sound. Okay, you will pass the sound here. What will happen? It strikes and it will come back to the same medium. Okay, so at the point of incidence, we will draw normal. At the point of incidence, we should draw one normal. Okay, so now see here this angle of incidence. Okay, this angle is equal to the angle of reflection. Okay, so that is, we can say that I means angle of incidence is equal to the angle of reflection. And here also same, this incident, normal and reflect all lie on the same plane. All lie on the same plane means same side. Okay, so these are the laws of reflection of sound. Okay, so clear? So reflection of sound means the bouncing back of sound is called reflection of sound. Okay, the bouncing back of sound is called reflection of sound. So clear? Next move to echo. Okay, you know, for example, just imagine you are near a mountains or walls. When you make a sound, you can hear your sound again and again. Suppose if you visit a Gol Gumbaz in Bijapur, okay, that Gol Gumbaz, when you produce a voice or when you make a voice, what will happen? You can hear that sound, okay, many times, many times. So okay, so we call that as echo. Okay, then suppose just imagine you are in a classroom. You are in a classroom, so no one is there. Okay, you are alone sitting in your class. At that time also, when you make a noise, what will happen? So you can hear your own noise 2 to 3 times. Okay, so we call that is echo. Then what is echo? Echo means the multiple reflections of sound. What is that? The multiple reflections of sound. Okay, so but when your friends all are sitting in the class, okay, at that time if you make noise, then you can't hear your voice again and again. So we will see that later. Okay, so first, you know, echo, this happens not everywhere. Okay, in some places only. There are some conditions are there. For example, see here, you know, at 20 degrees Celsius, at 20 degrees Celsius, at 20 degrees Celsius, the speed of sound is 342 meter per second. Okay, at 20 degrees 342 or 346. Okay, or sometimes we can say that 344 hours. Okay, just take 344. The speed of sound is 344 meter per second. Okay, now say one person is making noise. Okay, he is producing noise. Okay, see, if you want to hear that echo, minimum the distance between, for example, see here, this is a wall and here one person is making noise. Okay, if you want to hear the what noise, if you want to hear the noise, then he should produce a sound, and that sound it should come back to his it should come back to his here, right? So then he can hear the sound. Okay, the distance between this person and this one, the time taken to hear that echo, minimum 0.1 second. Okay, minimum 0.1 second. Then only he can hear the echo. Okay, he can hear the multiple reflections. Clear? And one more thing. Okay, so the time to hear the echo is that is minimum 0.1 seconds. Okay, so wherever you can produce a sound after 0.1 seconds, then only we can hear the echo. Echo means that multiple reflection means if you say A, for example, if you say A to you'll hear that letter A again 2 to 3 times. Okay, that possible when you produce a sound after 0.1 second, then you can hear that letter A 2 or 3 times. Okay. Next. So now see here the distance between. Okay, so what is the time taken to hear echo? That is 0.1. The speed is 3.344 meter. With the formula, distance is equals to speed into time. Speed into time. So what is the speed? Speed is 344 into 0.1. So what is the answer? 344 into 0.1. 344 into 0.1, that is 34.4 meter. 34.4 meter, which means here one more. Okay, so that say person A, this person, you can hear that echo when the distance first you produce the sound, it will travel. Okay, then it will come back. Echo means what? Okay, so first when you produce a sound, if that sound it will strike the obstacles, then it will come back. Clear? Then it will come back. So then only he can hear the echo. Clear? So here the distance from the see here that the sound it should travel that distance of 34.4 meter. Okay. First it will travel, then it will come back, right? So here speed is 344 and time taken is 0.1. So after 0.1 second, see when you produce a sound. After that production sound, so 0.1 second. After that 0.1 second, then only you can hear the sound. So which means that sound it should travel 34.4 meter. Then what is the distance between the person and that obstacle? Okay, see here that sound. Okay, see that sound can the person he can hear that echo after 0.11 second. In the 0.1 second, which means that sound it should travel from the person to obstacle, then it should come back from obstacle to person. Then only he can hear the echo. Okay, see here that sound it will travel from here to it will travel here to here, then here to here. See, it will go from here to here, then it will come back here to here. Okay, see this entire journey what it will take within a 0.1 second. Okay, then to hear an echo, the minimum distance between the person and the obstacle is that is just divide this one. Okay, 17.2 meter. 17.2 meter. So then only echo takes place. The minimum distance between the person and the obstacle, that should be equal to 17.2 meter. 17.2 meter, then 17.2 meter. So total 34.4 meter. Okay. So to hear an echo means what? The multiple reflections of sound. Okay. So what is the minimum distance from person to the obstacle? That is 17.2. Okay. See, if you want to hear echo, for example, you are in a classroom. Okay, the distance between your classroom walls and you, it should be equal to 17.2 meter. 17.2 meter. Okay. This is about echo. So echo means what? It is a multiple reflections. Means when you say a word, say India, you will say a word India. Okay, then you can hear that India word 2 to 3 times. So we call it as a echo. Okay. So next move to reverberation. See, in auditorium halls, it's a big, right? what happens means, there when you produce a sound, when you speak there, okay, at that time what will happen, that when you while speaking your sound which repeats again and again. For example, if you say Karnataka, in order what will happen, you can hear, just imagine I am speaking, you are sitting in that auditorium hall. If I say word Karnataka, then you can hear that word Karnataka 2 to 3 times. Okay, why? Because in auditorium we have to we have to speak in front of 1,000 or 500, 2,000 people. Okay, so that's why it is so what this creates what little some kind of some problem. So means we can't hear the proper sound. Okay, so that's why the roofs of the roofs of the auditorium, they use some kind of special fibers. Okay, they use some sound absorbing materials, okay, the roof of the auditoriums. At that time what happens means, those materials, they will absorb the sound, which means by doing that we can avoid the reverberation, means that multiple reflection. Okay, so here the walls, the roofs of the auditorium and walls of the auditorium are what made up of some sound absorbing materials. Okay, so just to avoid that reverberation. So clear? See, a sound created in a big hall or wall persists by a repeated reflection from the walls until it is reduced to a value where it is no longer audible. Okay, the repeated reflection that results in the persistence of sound is called reverberation. What is the sound? Reverberation. The repeated reflection that results in the persistence of sound is called reverberation. Okay, so to avoid that reverberation, what will so here while making that auditorium, while constructing auditorium, so we should use some sound constructing materials, means we should use roof and walls. Okay, those walls and roofs are should be made up of what, some sound absorbing materials, so then we can avoid the reverberation. Okay. Yes, sir. Next, yes, here, when you are just when you are in a school, you are single, no one is there. At that time, when you speak, you can hear your sounds many times. But when all the students are there in school or your friends are in school, at that time, if you make noise, then you can't hear your voice again and again. Why? This is why, because your friends, okay, because they will carry bags and they'll wear dress, right? So even our dress, some benches, everything, those materials also, they will absorb sound. Okay, by absorbing that sound energy, there is no chances for echo. Okay, your friend's bag, your bag, everything, those all are some sound absorbing materials. So that's why your friends, when you are with your friends in a class, in a school, so at that time you can't hear any echo or reflections. Suppose, just imagine you are sitting in a school. Okay, no one is there. Okay, at that time, if you make sound, then you can hear that sound again and again. Then you can hear that clearly. But when your friends are there and your friends are you, at that time you can't hear that echo. Why? Because your friends' bags, their dresses, everything. Okay, everything, they will absorb the sound energy. So that's why you can't hear that echo. Okay. Yes, sir. Next, move to uses of multiple reflection of sound. Okay, now we have discussed it. What in auditorium hall? In auditorium hall, what will happen? So we use some sound absorbing materials just to avoid the echo, just to avoid the multiple reflections. So now, what are the uses of multiple reflections? We will see now. Megaphone. Okay. Okay, this is a megaphone. See here it will produce a sound. Okay, if you use see, if you talk in front of say 100 to 200 people, okay, then your voice is not audible for 100 or 200 people. But if you use, why? Because here if you use, see, if you talk like this without using any instruments, okay, what will happen? Then sound it will move in all directions. Okay, that sound it won't cover longer distance. Okay, suppose if you use these megaphones, what will happen? See here you should produce a sound here, you should talk, speak here. Then what will happen? Then what? So here that sound is sound energy, it reflects again and again inside the microphone, inside this megaphone. Okay, then it will move, then it will cover. Okay, then that sound from this megaphone, it is audible for 100 or 200 people. Okay, so here what happens means, see, if you want to use this megaphone, if you speak here, what will happen? Then sound will move in all directions. But if you use this megaphone, what will happen? Entire energy is concentrated through this megaphone only. So here that sound, and what happens? Here it undergoes multiple reflections. Okay, then it will come outside. Okay, so then the sound from this megaphone, so it is audible for 100 or 200 people. So that's why we use this megaphone. Okay, just to address many people. Okay, next, and even this one also. Just imagine this is a megaphone with a horn. Okay, you have seen in government buses. Okay, yeah. So here also, when you press this, just a minute. Okay, so this is a horn. Okay, so when you press this horn, what will happen? Here sound is produced. Okay, then this here it is completely closed. Okay, so then when you press here, what will happen? Sound produces. Okay, then that sound it won't come outside. Why? Because it is completely closed. So that entire sound energy, it will pass us through this pipe only. Okay, then here also that sound it undergoes multiple reflections, then finally it will come outside. While coming outside, it will come with a huge amount of speed and it will cover longer distance. Okay, but see here we can't speak loudly every time. Okay, see, once we can shout, but we can't talk half an hour, we can't shout continuously for half an hour or 1 hour. Okay, so that's why here we use these horns in vehicles. So here also we use multiple reflections. So using the multiple reflections, we can produce a louder sound. Okay. Next, and yes, next, in we use this multiple reflection in stethoscope. Okay, yes, to know the heartbeat. Okay, we use that stethoscope, right? Even that stethoscope also. Okay, so in that stethoscope also. Just imagine this is a stethoscope. Okay, so here also, they will keep in for the heart, right? So then this absorbs that sound of an heart. Okay, then that sound it undergoes continuous reflections. Okay, see in a normal without using the stethoscope, so we can't hear the heartbeat. Okay, so here the sound from the heartbeat. Okay, first it captures this stethoscope, then what will happen? Then multiple reflections takes place, so then we can hear the sound of heartbeat. Okay, so we use that multiple reflection in stethoscope also. Next, in we're in a conference halls and cinema theaters. Okay, usually they'll keep the speakers behind the screen. Okay, then what happens means their walls they are used what some non-absorbing, here use some materials. Okay, then this sound energy what will happen, which falls on the walls of the auditorium. Okay, then that sound it undergoes reflection. Okay, so then audience can hear the sound clearly. Okay, so we use in for conference halls and auditorium also. Okay, so this is about the uses of multiple reflections. See, first we use in a megaphone and arm, then we use a stethoscope, then we use these multiple reflections in conference hall and cinema theaters. Okay, there are other some multiple applications are there. Okay, yes, sir. So next move to range of hearing. See, before that we'll discuss that range of hearing tomorrow. So before that we'll discuss one problem related to an echo. See, first I'll write that question. See. Okay, let's see here. Small problem. A person clapped his hands near a cliff and heard the echo after 5 seconds. Okay, he heard the echo after 5 seconds. So, what is the distance of the cliff from the person if the speed of the sound is taken 346 meter per second? Okay, see here. First, we should have calculated. We know the formula. First, write unit. So, time t equal to 5 seconds. Okay, then speed means v, that is 346 meter per second. We know the formula, speed equal to distance by time. We need distance, right? So v into t equal to distance, or we can write d is equals to v into t. So what is v here? P is 346 and what about time? Time is 5 seconds. Okay, so 340 seconds into 5. So what is the answer when you multiply? So you will get 1730 meter. Okay, the distance. Okay, see here they are asked what is the distance of the cliff from the person? The distance between person and the cliff. Okay. See here, see echo means what? For example, say this is a person. Okay, so this is a cliff. Just imagine. Okay, so now this person he can hear. See, he will clap, right? Okay, see, he can hear that echo. Echo means first that sound it should travel from this point, then it should strike this cliff and it should come back. First it should travel, then it should come back. So it will take 5 seconds. 5 seconds. Okay, then what is the distance between this person and the cliff? And we got that while traveling, so the speed of that echo or that distance covered by that echo is 1730. So that 1730 is so the total distance of that echo means first from here to here and then here to here. This total distance is. I'll stop here. So tomorrow I'll continue the class. Thank you. In tomorrow's class we will discuss the range of hearing and applications of ultrasound.